Sometimes when we use op-amp circuits, in the feedback we have a complex network, as shown here, instead of just one resistance on the feedback. How do we analyze these kinds of circuits? One of the ways in which we can analyze these circuits is by using the concept of Thevenin equivalence. Okay, and what we can do is we look at we put an imaginary line here and look into the circuit on this side and try to find out the Thevenin equivalent of the circuit. Okay, so we want to find out the Thevenin voltage and the Thevenin resistance. Now, the Thevenin resistance is fairly straightforward, isn't it? Because if V out is a source, so let's say the op amp is outputting V out, to calculate RTH, we make V out equal to 0, and then we look at the equivalent resistance on this side, and that just turns out to be R3 parallel R4. Okay. Now, what about calculating VTH? Now, to do that, what we do is we open the circuit at this point and look at what the voltage is because of this V out. And what we find is what the V out that we get is the Thevenin voltage then is V out times R4 over R3 plus R4. So now what we can do is we can replace the output part of this circuit and redraw the circuit in the following way. So let's do that. So we have our op amp here. The non-inverting terminal is of course connected to ground, and the inverting terminal, the input resistance is same, it is R1, and in the feedback you have the resistance R2, but after R2 we are going to replace it with its Thevenin equivalent, and I'm just going to draw it in a different color. And instead of the combination of R3 and R4, we'll have RTH, right? And the op amp outputs, let's say, a voltage of VTH instead of the output. So instead of V out, we now get a voltage VTH at the output of the op amp. Okay, so now we can analyze the circuit a little bit more, and we can find out the relationship between VTH, the Thevenin voltage, and V in. And what is that going to be? So VTH over V in is going to be R2 plus RTH over R1, and it's going to be a negative sign because this is a inverting configuration. Okay, I've made a small mistake here. This should be the inverting terminal, right? You can't have two non-inverting terminals in an op amp. Okay, and now you can substitute back for VTH from the equation that is there here, and then you will get the relationship between V out and VTH. So let's do that. So if we do that, what we get is V out over V in equal to minus R2 plus RTH over R1 times R3 plus R4 over R4. We could also substitute the value of RTH, right? Because RTH, what is it? RTH is given by R3 parallel R4. So I'm just going to write that as well here. So you have R3 parallel R4. Okay, and you can resolve this equation. I'm not going to do the arithmetic. I'll let you do it. But what you would get is this R2 plus R3 plus R2 R3 over R4 divided by R1. And that's how you can resolve circuits which have complex networks in their feedback, basically by using the Thevenin equivalence.